Thanks everyone, and apologies for technical difficulties. My name is Chiu-Ki Chan, and I'm an Android developer. Today I'm going to do this talk about supporting multiple Android device definitions. But before I start, how many of you have written at least one Android app? Okay, so for the rest of you, I'll probably go through Hello World just so that you have some background before we jump too deep. So one thing that scares people about Android is that there are so many different devices. There are tablets, there are phones, and there are different sizes, different resolutions. And people are like, how am I going to code for so many different devices? But the truth is, it's not that different from web development. I mean, you can resize your browser and essentially get infinite screen sizes. And we have dealt with that for the longest time. So today I'm going to show you different techniques that you can use to make sure that your app works no matter which device it runs on. The two techniques that I'm going to cover is responsive and progressive. We're going to get into examples and it will be much clearer what I mean by that. But first, let me show you Hello World, just so that everybody has a background. So this is a very boring app, Hello World. All it does is displays the string Hello World. The way you will set it up in Android is that you will have an activity. So in our case, it will be a domain activity. And you will give it a XML file, which is called activity_main, and you will set it in the Java file. That corresponds to an XML file under the directory layout. So you can see r.layout.activity_main corresponds directly to the directory structure. Inside that XML file is this, essentially, a very simple text view. So all I'm telling Android is like, please display a text view. And I'll give it an ID, which if you have done web development is very similar. You can search by ID, like that. And once we get back to the Java code, you can see that I can look for this ID by calling the function findViewById. And then once I have that, I can set the text on it. So that's just a very quick overview of how this Android works, just to give you an idea of how things are hooked up together. And then we're going to go over how do you actually set things up within the screen in Android. So let's say we want to build something like this. We'll have a button on the screen. Well, how will you go about thinking about that? Well, you can either think that, oh, I know the XY coordinate of this button, so I'm going to put it right there. Not a good idea. So let's say we have this just one phone, we're not even multiple devices. But people can rotate that device. Now, if you have an absolute coordinate, then it will be still there. You tell it to be at that XY coordinate, and it will look silly. Like, what does that coordinate even mean? So by declarative layout, what I mean is you think about what it means. Like, why do you want that button to be in that particular position? So in this particular case, the semantic of the button is we want it to be at the center. So rather than giving an absolute coordinate, you give it a declarative position. In Android, it's pretty easy to do. What we do is we have a button, and then the width and height of wrap content means just take as much space as you need. And then I will say layout gravity is center. Then the system will know to where to put it. It will compute the exact coordinate based on the fact that you want it in the middle of the screen. So now let's go through a more complicated example. So let's say we have this game of find the difference. So we have two images. And by the way, can you find the difference of these two images? Nobody?
French.
Yeah, so the little spanner wrench thingy, like one of them has two thingies sticking out. I don't have any technical vocabulary about tools, clearly. And the other one has three thingies sticking out. Yeah, maybe should we turn down the lights actually? Would it be easier if
Don't know if easy
or
is...
maybe we should not touch the controls, I don't know. So now, like,
you know what,
don't want to take any risks.
Let's leave it.
Yeah, today is not my best day with technology, so anyway, there will be no more find the difference game. So that's the only slide that you actually need to be very, very careful in looking. So now how are we going to implement that, bearing in mind that we want to be declarative? In Android, what you can do is you say that we have a linear layout, so meaning that things come one after another, a vertical one, so stack them vertically, and we have two image views, each of which we don't know how big it's going to be, but we're going to tell Android the weight. So you can see that both of them have weight of 1. This means that I want them to be equal. So no matter how big the screen is, each image will still take 1/2 of the screen, right? So instead of like hard coding, I want it to be 400 pixels, right? And if you do that, then it will look funny on the screen that is not 800 pixels tall. So now I show you that layout. There's actually something that I did not specify in XML yet, which is this divider. So I want to draw a line between the two things. When you do weights, you can also mix it in and give it a specific height. So the two will take the remaining space. So for example, the divider in the middle will take 1 dp, and then the rest of the screen will be equally divided between the two images. 1 dp. Usually we think about pixels when we talk images. What is this dp business? 1 dp is 1 density independent pixel. So this is a concept that Android has, which means that, let's say we have some different screens. Some of them are better in the sense that it has more pixels to represent one physical area in real life. So if you specify things in pixel size, then if you say 1 pixel will be teeny tiny on this awesome screen that people can't see it, versus if you say that it's 1 dp, then maybe on this particular device, to display 1 inch, it will take, I don't know how many pixels, 200 pixels, versus a less dense device, which is 100 pixels. But then if you specify it in 100 dp, it will scale automatically. So back to the same device we have. Again, we'll turn it and see how it looks like. Well, Android is very faithful, right? It tells you, I want it to be stacked top to bottom and then divided equally. But it looks like we're wasting a lot of space here. What we prefer is actually, if we are in a landscape layout, we want it to be side by side. So how do we do that? We will introduce a new file to Android called layout land. So land stands for landscape, and define the way we want. So in this case, we want the linear layout to be horizontal, and we have the same weight, but we are dividing the width instead of the height. So very similar to what we have earlier. Now, what does that mean to have this layout land folder? If you remember what I explained in the Hello World instance, we have this folder that's layout. So that is the default. So everything will go through there, except if your device matches some specific specifications. So in our case, the layout land folder, that particular XML will be used when you are on a landscape orientation on the device. You don't have to change your Java code. You are still saying that, hey, I want that file called activity_main. And Android at runtime will figure out, like, oh, hey, I have this device, this is the landscape, so I will not load the default one, but instead load the specific one. So this is how you can customize things in Android. And resource folder is very, very powerful. So we're going to go through some more examples. Now let me show you a little bit of a flavor of what's available. That's more than that. So we saw earlier in the orientation, we can do portrait landscape, but we can also do different things. For example, DPI, which is the density. A very common thing is when you have the launcher icon, which means if you have an Android device and you want to go into the app, that particular app icon, you probably want to provide different densities for different devices so that they look good even if your device has many pixels. So in our case, images in Android are in the drawable folder, so we'll have drawable-hdpi. So you can combine this in many different ways. You can even have multiple. So if you want a particular image that is only for big screens, that's what the large thing means, and landscape, so kind of like a tablet. So saying large is a little bit old school. If you see the screen size line, I also have listed things like SW320dp. So that means smallest width is 320 dp. That's a more precise way to tell Android, oh, okay, if the smallest width of the device is larger than this number that I specified, then go ahead and use this particular resource. So I'm going to go through an example. So this is my app. It's called Monkey Write. Teaches people how to write Chinese. And in our case, I'm going to show you this particular one, which is when you run it on a tablet. So when you run it on a tablet, I have a lot of real estate. So I have this beautiful background. Hopefully you can see from the projector, there's bamboos in it. Well, monkeys don't live in bamboo forests, but you know, it looks Chinese. So I have this nicely textured, beautiful background that, unless I point it out, nobody question. Which, if you think of it, if I want to put it on a phone, it gets a little bit busy. So on the phone, what I do is that instead of all those nice bamboo, I just have a gradient. So it still looks nice, but it's different, right? I want to do something different when it's a phone versus when it's a tablet. Notice that when I specified this is the default one, it's .xml, versus previously we have a .png. So in Android, not only that you can give image files to use as images, you can provide XML drawables. XML drawables in a declarative way to tell Android what to draw. That particular background, I'm sure everybody is very well versed in hex code, right? So the start color is 063, which is a shade of green, and the end color is 030, which is a darker shade of green. So you tell Android essentially, I want a gradient that goes from this shade of green to that shade of green, and the angle is to configure from which side the gradient sweeps. So this is the resulting gradient, which is great because it's infinitely scalable, because Android just computes at each pixel what value of the color it should be. Rather than, I mean, you can probably just do a PNG file if you know how big your screen is. But if you do that and your screen is way bigger, like you put it on the Android TV, then what will happen is that you have bands, right? Because the number of different colors is limited in the PNG that you provide. So, but with a declarative layout, you can do it as big as you want. Android will just go ahead and faithfully compute the value. So that's one way to be declarative. Another thing people may want to do is to put a pattern as their background. I'm sorry, probably you can't really see too well. Just imagine in your head, this is a honeycomb pattern. So you have a very nicely regular hexagon. Now, if you just naively take that particular image of that particular aspect ratio and just say, hey, use that as the background, and you rotate your device, it will get stretched, and then instead of honeycomb, it looks like corn on the cob. So it's kind of not thematic anymore. So what we can do in this case, if we still want honeycomb in our background, is that we can tile them. So tiling is a pretty old concept. I hear someone laughing. Yes, this is from GeoCities. Who knows GeoCities? All right, I'm talking to the right crowd. So GeoCities has been around for at least like 20 years. And people know how to tile backgrounds back then. So we can just take the same technique and put it on mobile, right? If I want a background that has texture, and I want to be able to cover as much surface as I want, we can tile it. But Android takes it one step further. Instead of just saying, I'll tile it one after another, it provides a tile mode. So in this case, I'm telling Android, hey, I have this one tile, tile.png, use this and repeat it one after another, which is the normal way of tiling. And then afterwards, once you have that, what you can do if you want to use it is in the background, you can see Android background. You can refer to the XML definition of basically where's the source image and how do you tile it. And then you can just call it like a normal drawable. So the tile mode, what's interesting is that repeat is the normal one that we normally think about, but the mirror mode is the best, in my opinion anyway. Because if you have a tile that's just cut right after another, you have to be very careful when you generate that tile image to make sure that at the edge, things are connecting to the next one. Otherwise, everybody can see that it's tiling, which sometimes is not bad, but a lot of the time just you don't want to draw attention to the background, right? For mirror mode, then what it does is Android will automatically flip at the edge, so you will automatically get seamless tiles. So I love that because I'm not a graphic designer. I can open up GIMP and pretend, but lining up pixels so that all the edges, no, that's just way beyond me. So fortunately, I can just cheat and use mirror mode and say, hey, look, there's no seams, yay. So back to MonkeyWrite, my app. So this is one screen in MonkeyWrite that I use a GridView for. I want to show the different characters that you can learn. So now think about it. Like, how are you going to tell Android to put these characters on? So one naive way to think is, okay, I will tell Android to put 4 characters on because on this particular device, I have room for 4. Now, if I'm on a phone and I want to put 4 characters on, they will all be teeny tiny and kind of look silly, especially because I have little star ratings in the bottom. So instead, what you can use is, instead of the number column 4 being a number, you can tell Android, hey, just auto-fit. Just fit as many as you want. Well, now you have to tell Android more than just auto-fit, because you have to tell Android how big each of the characters are. So in that case, we'll specify the column width and also the padding. There's something a little bit interesting here. Notice that I didn't put directly 60 dp or whatever numeric value you want. I'm actually putting it under @dimen. So this is something that you can do. You can put it in a separate file called dimen.xml. And what it can do, it can specify the values here. The nice thing is, I'm going to use the same padding for both vertical and horizontal. So if I do that, then I'll have one single place to change it. Moreover, the same trick applies. So I can also make a folder that is values-large. If I do that, then when I'm on a large device, say a tablet, then I can have bigger characters. And I don't have to touch anything else when I'm using the rest of the XML file that refer to this dimen file. It will just pick the correct one. So all the logic remains the same when I just say, hey, I have a grid view, I want auto-fit, I want you to compute it based on column width. So column width will be picked from the correct folder depending on what device you run on. So the result is, if I run it on a 7-inch tablet, the previous image was from a 10-inch, it will put 3 because it just do the math and say, hey, I can fit 3. But if I'm on a phone, then it will fit 2. So you can still get the size that you want per item, and Android will just like, well, I can do math. I can just tell you how many I can put in. And then the rest will just flow. So one thing I do want to mention is fragments. So another way that you can think of Android layout is that if you have a big screen, then you can kind of fit multiple of them, right? So fragment is a unit that you can use for that. So for example, on the phone, maybe you're on Gmail, right? And you have a list of all your emails, and then when you click on one of them, it will open up the next screen to see it. On the tablet, you can actually just have the list on the side, and then when you click, it will show side by side. So fragment A will be the master view, the list view, and then the fragment B will be the detail view. So fragment is a really big topic. I'm not going to go too much into it, but that's one thing that you want to bear in mind. This pattern was introduced when Android first came out with tablets, and there's like a big debate between whether you want to use fragments or custom view. The idea is that you want reusable components. The link here is not my repository, it's another repository that you may want to try out. All right, so all that was responsive. How do we make sure that our code responds to the particular device that you're running? Let's look at progressive. Progressive enhancement means that you're going to add functionality on devices that have it, but all devices will still work. So you're not just going to be like, hey, use this newest thing, and then your app run on an old device and it just blows up and crash. So we've seen this slide before. Why are we showing this again? Turns out that one of the resource folder you can use is the V one, which is specify the platform version. So I'm going to go through an example, which is ripples. Ripples is a nice visual effect, so when you click on a button, it will ripple out. This was introduced in Lollipop, which is API level 21. So if you want ripples, you have to run it on a device that's level 21. Now, you can either just say, okay, my app only ever runs on anything 21 or above, but then you'll lose a lot of users if you cut it there. So you can also say, I don't want this because I don't want to have an app that only works on 21 or above. But then you want the new things, you want all the cool things. So progressive enhancement is a way to resolve these two conflicts. What we can do is we can make something that is in drawable-v21 and use ripples. So like I said, much like the landscape versus portrait example, when the device is run and it has OS version 21 or above, it will load this file and then it will use ripples. But make sure you put in a default in the drawable folder, because if you don't do that, then if you run this on an older device, it will be like, I don't know what to do. Like, there's nothing I can do. So in this particular case, for the backup, what we have is a selector, which is a solid color. So we will have it be one color, the primary color, normally, and then when someone presses on it, it will change to the accent color. And then the same deal, you are just going to refer to this drawable by its name, and then Android will pick it from the correct folder at runtime. So this is how it looks like. The one above is before version 21. When you click on it, the whole thing changes color. And then if you run it on version 21 or above, then it has this nice ripple effect, which is more fancy. And as the platform gets more mature, you probably want to make sure that you incorporate new elements, otherwise your app will start looking very dated. Another way to do that, if you want new APIs, but only on new devices, is in Java. So for example, you're browsing through the Java doc and you're like, hey, this is exactly what I want. I'm going to use it in my app. But then you realize that it says API level 5, which at this point, all the devices are probably running 5 or above. But let's say you're like, I have to support everything from version 1 and make sure they work. Then what you can do is you can use this constant that is SDK_int, which tells Android which version the device is running. So you can look at it during runtime using Java. Now this is kind of like a formula to do progressive enhancement. So we set up a default value, so in our case we want the heap size to be 16. And then we look at what version we're running this on. And then if we say, oh, it is actually larger than Eclair, which is the code name for version 5, then we can go ahead and call this get the heap size programmatically. So this is a helper function because I don't have room on this screen. So the getHeapSize is going to call the getMemory class function that we saw in the Java doc earlier. So in this case, we have a sensible default value for devices that are too old. But if the device is new enough, then we can call this extra nice function and get the new functionality. Another way, if you want new functionality, is you can ship new functionality with your app. Right? So if you are trying to call things that are on the system, then you're dependent on the system. And Android actually has been using this for a long time to be able to give us developers functionality that we can essentially use on all devices. So the official support library has a lot of different things in it. This is just a subset of it. It's kind of interesting how it evolved. So basically what happened is that, oh, okay, Fragment, like I mentioned earlier, is a great way to do tablets, but older devices don't have that, so how are we going to let people use Fragments? So they put that into the support library. And then from that on, there are a lot of different classes that get into the support library. So I just want to focus on one particular one. It's called AppCompat. So in, I think, Lollipop, when it launched, it came with material design, which is a new way of how the apps look like. So if you haven't used Android for, I don't know, 6 years, and you look at material design, it's very different from what Android launched with. So this look and feel, again, you don't want it to be just on the newest devices. So if you use the support library, then you can use AppCompat, and then that will style your app to look like this no matter what version you run on. I think, from 7 or above. So if you're really supporting like version 1, then you're out of luck. So this is one thing that you can do to bring new functionality to old devices. And the support library also was interesting because I think Android ended up launching some new functionality that is only available in the support library. So they didn't bother bundling it with the OS, with the idea that way, whenever they have a new version, bug fixes and whatnot, you, the developer, can just include a new dependency and you will have the newest code. You don't have to depend on the device OS to update. So in summary, we've gone through different techniques on how to do responsive layout and to do progressive functionality. One big thing, if you walk away with one thing from this talk, is you want to think declaratively. You want to think about what is it that you want to do, and you essentially explain to the computer, say, hey, I want this to be in the middle of the screen. With that, that will help you a long way into structuring your app in such a way that it will work on multiple devices. And then I also explain what is the DP, resource folders, and how do you make XML drawables. And then to make progressive functionality, again, we can use the resource folders, but then we can also check the version code in Java, or we can also just ship the new functionality with the support library. So I have this really big note on the side, so the slides are online. If you're interested in checking this out later, you can write that down and then you can go back and refer to the whole deck. And with that, thank you very much. If you want to learn more, the top link is kind of the official training that Android has on the website about how do you deal with multiple screens. The other two links, the is.gd links, are other presentation that I made about. So the fluid Android layout talk, that one is actually a lot more about Monkey Ride, my app. Like how did I make it so that the layout is fluid, so that it will work on many different devices. Beautiful Android goes into more of those tricks that I told you, like how to use XML to specify drawable. So for example, if you want to make a button that has round corners, and when you click on it, it changes color, you can do that all in XML and declaratively. And the last one, Pluralsight. I am a Pluralsight author. It's a video class website. So you can go there and watch courses that I made on layouts and custom components to learn more about how to do Android. And then you can find me on Twitter. That's my blog. And then also I have a newsletter if you're interested in following what I do. And last but not least, there is going to be an Android conference that I'll be running with 2 other people end of this month. So it's July 28th and 29th, right here in Denver, called 360 AnDev. If you are interested in Android, I highly recommend you go there because we have a lot of great speakers. We have like speakers from Google, and we also have a core track. So for people who are just getting started on Android, like we'll have content to learn things like what is an activity? How does it transition from on pause like back to on resume? Fragments, like I mentioned. So we will actually have a full course on that, and a lot of other topics. And I actually brought a discount code. So if you're interested in joining the conference, you can register and get a discount. And I brought stickers as well. They are at the food table.
Awesome.
How much off?
It's 15% off.